Have you ever swum over a mountain? Not in a dream, not in some movie's CGI fever dream. For real, on a ship, hundreds of feet up in the open air, gliding above terrain that's supposed to stop boats dead. You can do it right now, and there is exactly one place on Earth where it's possible: China. Of course it's China. Sit with that for a second, because here's the number that should bother you. China produces 391 gigawatts of hydroelectric power. The entire rest of the planet combined. Every dam, in every other country, on every continent, adds up to 1,360. So China alone is about a third of all the hydropower humanity generates. One country, a third of the world. And if you pulled up a ranking of the 5 largest hydroelectric plants on Earth right now, all 5 of them are Chinese. Not 3, not 4, all 5. The Three Gorges Dam alone runs at 22.5 gigawatts of installed capacity, the single largest power plant of any kind on the planet. The next biggest? Also, China. The pattern doesn't break. It just keeps going, all the way down the list. And I'm going to show you something the engineering world itself calls a marvel. A place where ships get lifted into the sky like they weigh nothing, where boats climb higher than the Statue of Liberty, higher than the Great Pyramid, where the West, frankly, has nothing that compares. That sounds made up. It shouldn't be possible, but it's real, and you're about to see exactly how they pulled it off. So if you like watching the impossible get built, hit subscribe right now, because this is the channel for it. And stay with me, because the second half of this story is even harder to believe than the first. Here's the what. Deep in Guizhou province, in China's mountainous southwest, there's a dam called Gupatan, and sitting next to it is a tall, windowless building that a ship sails into. The vessel comes up the canal, drifts in through the doors, and stops, floating in a pool of water inside the structure. Now look at what's around it. A lifting cable, 2 rows of drums to wind that cable, gearboxes braced on both sides of the chamber. Picture the elevator in your apartment building. Except the thing it carries isn't a person, and it isn't a sofa. It's a 500-ton ship, fully loaded, riding in its own private lake. And it raises that ship in about 10 minutes. Think about what that actually feels like. You're standing on the deck. The doors close behind you. There's a low hum, a faint shudder through the hull, and then the world outside the window starts to drop. The canal you sailed in on falls away beneath you. The trees shrink. And in the time it takes to make a cup of coffee, you and your ship are floating where no boat has any business being. The lift climbs at about 8 meters a minute, slow enough to feel safe, fast enough that you watch the landscape sink in real time. Now here's where it gets insane. Each of these lifts can handle up to 1,800 tons, and the system carries you to a height of 653 feet in total. So how did they actually pull this off? Here's the answer that breaks your brain. They didn't build 1 lift, they built 3. A staircase of elevators, stacked up the side of a mountain. This is the part that's never been done before anywhere on Earth. Gupatan is the world's first 3-stage vertical ship lift. The vessel clears the first elevator, then it slides into a second one. And that second lift is the single tallest ship lift on the planet, a vertical rise of 127 meters in one move, about 417 feet in a single shot. Then a third stage. Enter, wait, rise, enter, wait, rise. And by the time a ship has gone all the way through the system at Gupatan, it has been lifted a total of 653 feet into the air. That's not me rounding up. That's the official figure. 199 meters of elevation, conquered by 3 machines in a row. Let that sink in. 653 feet. That is the height of a 66-story skyscraper. If the Great Pyramid of Giza were standing right next to you, and the pyramid is 456 feet tall, you would be looking down on the top of it from your boat. The pharaohs built that thing to scrape the heavens, and you'd float right past its tip with room to spare. The Statue of Liberty? 305 feet. You wouldn't even mention it. You'd be more than twice as high, drifting past it like it's a garden ornament. And then, because the reservoir behind the dam can rise and fall, the final stage has to adjust to meet it, lowering or raising you by as much as 154 feet depending on the water level that day. Up, and across, on a ship, through a mountain, 3 separate machines, playing with hundreds of feet of height like it's the easiest thing in the world. Now, I know exactly what you're thinking because I thought it too. You're skeptical. Ship lifts aren't new. They've existed around the world for over a century, so what's the big deal here? And the throughput has to be terrible, right? One ship at a time, crawling up an elevator, while a normal river lets dozens of boats flow freely at once, just keeping a safe distance from each other. And on that last point, you're not wrong. This system will never match the free flow of an open river. That's a real limit. I'm not going to pretend it isn't. But here's the part nobody's talking about. The lifts run as a line. The system was deliberately split into 3 separate stages by the engineers at the Changjiang Institute for exactly this reason, so that the moment one ship clears the first elevator, the next one can already be loading in behind it. Up to 3 vessels can be moving through the system at the same time, 1 per stage. It's a conveyor belt of ships climbing a mountain, one after another after another. They didn't beat the throughput problem, they just refused to let it stop them, and they engineered around it. And speaking of the route, there's a problem I haven't told you about yet. Those 3 lifts aren't stacked in one neat tower. They're spread across the terrain, and you have to cross the distance between them, and that distance runs straight through some of the most hostile ground imaginable. So between the elevators, the Chinese built open aqueducts, channels of water threaded into the side of the mountains. And then, where the mountains simply would not move out of the way, they bored a tunnel straight through solid rock and ran the waterway inside the mountain. The same kind of massive tunnel boring machines China uses to carve subways and high-speed rail beneath entire cities, turned loose on a mountain so a barge could pass through its heart. The result is a continuous waterway, aqueducts plus tunnel plus the lifts themselves, stretching 2.3 kilometers, about 1.4 miles, between the mountains and through the mountain. People built aqueducts in ancient times, sure. The Romans did it without a single power tool. But integrating one into a triple lift system, wedging it into a mountain range, threading it through bored tunnels and balancing the whole thing against a working hydroelectric dam, that's not ancient plumbing. That's a completely different sport. And here's the cost of doing it. The lift system alone, not the dam, just the lifts and channels, ran about $777 million. And it took them years after the dam itself was finished to build it. So now the obvious question hits you like a slap, because here's the twist. The dam itself isn't even the impressive part. Gupatan is a beautiful double curvature arch dam, one of the tallest of its kind anywhere, standing 232.5 meters, with 5 turbines generating a total of 3,000 megawatts and an average annual output of around 9.7 billion kilowatt hours. On its own, that's a serious piece of infrastructure, but put it next to one of China's newer giants, the Baihatan Dam. Nearly identical graceful arch shape. But Baihatan runs at a staggering 16,000 megawatts of capacity. Gupatan doesn't come close. It is not a record breaker. It isn't anywhere near China's biggest. So why? Why pour this much effort, this much time, $777 million, into a triple lift engineering miracle for a dam that isn't even special by Chinese standards? Now here's the kicker. The answer is the terrain itself. Guizhou is brutal country. The province sits on a plateau averaging around 3,600 feet of elevation. And here is the number that explains everything. 92.5% of Guizhou is mountainous or hilly land. 92.5%. Terrain that is flat-out hostile to normal transportation. You cannot just roll a wide highway through it. And when they built the Gupatan Dam, the dam raised the upstream water level by up to 199 meters. And in doing so, it severed the river. It cut the upstream from the downstream completely, isolating whole stretches of the Wu River from each other. The water level difference it created was so violent that the normal solution, the gentle staircase of locks boats usually climb, was simply impossible here. Too slow, too risky. To raise a ship that high with conventional locks would have been a nightmare. So they reached for the unthinkable answer instead, and they built it. Let me show you why that mattered enough to justify the price. Think about moving cargo through country like that. A standard heavy truck carries maybe 22 to 25 tons. Let's call it 23 on average. The Gupatan system is designed to move 2.928 million tons of cargo a year. And a single barge through that lift replaces several dozen of those trucks in one trip. Several dozen. Now picture those trucks instead, grinding along narrow, twisting mountain roads and over fragile bridges, slow and dangerous, in a region where building a wide highway is somewhere between difficult and impossible. Who needs that when you have water? Barges are far more fuel efficient than trucks. Rail is a little better than trucks, but laying track through these mountains is its own brutal fight, and the trains still lose to ships on raw efficiency. So despite every headache the lift system causes, the region got the best possible answer. And the rest of us got a breathtaking sight and proof that sailing a ship over a mountain is more than doable. And the reason they fought for the hydropower in the first place. Guizhou's hydroelectric potential ranks 6th in all of China. On the Wu River alone, there are 8 hydroelectric plants totaling 8,500 megawatts, and Gupatan is just one of them because the authorities simply could not ignore that kind of potential sitting in the landscape. It's all tied to a national program, China's plan to swing its energy sector hard toward green sources, with renewables set to make up a major share of the country's total energy in the coming decade. In a province that is almost nothing but mountains and rivers, the obvious play is to squeeze every drop of hydroelectric power out of the land. This is part of China's massive west-to-east electricity transmission initiative, generating power in the remote, rugged west and firing it across the country to the industrial east. Now let me zoom out hard, because this is where it stops being about one dam in one province. The Wu River is a tributary of the Yangtze, and the Yangtze isn't just any river. It is the longest, most water-rich river in all of Eurasia. 3rd in the world by volume of water, 4th by length, and the longest river on Earth that flows entirely within a single country. The Yangtze touches 1/5 of all of China's land. 1/3 of the country's entire population lives along its banks. Its delta alone generates up to 20% of China's whole GDP. So every landlocked region that isn't connected to the Yangtze would do almost anything to be plugged into it. That is what this is really about. When you connect a remote mountain province like Guizhou to the Yangtze, you are not building a tourist attraction. You are wiring an isolated region directly into the economic bloodstream of the most populous nation on Earth. Energy and a transport artery in one single stroke, reaching the Yangtze mainstream and the trade routes beyond it. And while we're naming names, this is exactly the kind of infrastructure the United States, Germany, and Japan talk about, study, and admire from a careful distance. China just builds it. Where the facts support it, the West is the one standing back and taking notes. But I promised you the second half is harder to believe than the first. So here it is. Because Gupatan's lifts handle 1,800 tons each, and you'd assume that's the record, it isn't. Go back to the giant the Three Gorges Dam, and its shiplift can raise a vessel of up to 3,000 metric tons. 3,000 tons, lifted as one piece. The water-filled chamber it rides in is 120 meters long, 18 meters wide, and 3.5 meters deep. And when you add the ship, the water, and the steel chamber together, the total moving mass this thing hoists is roughly 15,500 tons. 15,500 tons, lifted 113 meters. About 371 feet, straight up the face of the dam. It's slower than the multi-stage system we just saw, about 40 minutes for a single lift. But hold on, because this is one elevator, lifting a small floating skyscraper in one continuous move. You cannot underestimate what that takes. And here's a detail the China copies everyone crowd never mentions. The brains behind this lift were German. The design came from a German joint venture, Krebs and Kiefer with Lohmeyer International, working hand in hand with the Three Gorges Corporation. The project was approved all the way back in 1992, and the original plan was to suspend the entire chamber on steel cables. They scrapped that. The engineers feared the chamber could become dangerously unstable while lifting a ship. So in 2003, the German team came back with something cleverer, a gear-driven counterweight system built on a principle that is over 2,000 years old, Archimedes' principle, the same idea that explains why a steel Navy ship floats instead of sinking. Concrete counterweights, balanced against the water, do most of the work, so the motors barely have to strain, and the safety engineering underneath it is paranoid in the best possible way. There are 4 gear-driven mechanisms arranged symmetrically around the chamber, locking the ship in place at 4 points. Why does that matter? Because it stops the water inside from tilting or sloshing and dragging the whole chamber off balance with a ship sitting in it. It dramatically cuts the risk of the chamber overturning. and they built it for earthquakes. There are buffer and damping systems inside the chamber that absorb shocks and vibrations. And as the engineers have explained, in a quake, the design channels the seismic forces out into the tower columns, keeping the chamber from falling and preventing catastrophe. After it opened, the payoff showed up fast and it kept coming. The Three Gorges Navigation Company reported the dam's throughput in the first half of 2023 reached 84.15 million tons, a 9.32% jump over the previous year, a new historical high. And as of early 2024, this single lift had carried over 1 million passengers and some 15 million tons of cargo over the dam. And here's why China wanted that lift so badly. Before it existed, ships still crossed the Three Gorges Dam, but they did it through another engineering marvel: a colossal 5-stage 2-lane lock system, a staircase of water chambers. Each stage is 920 feet long and 115 feet wide, built to pass vessels up to 10,000 tons. Almost any cargo or passenger ship that travels the rivers can fit through it, but passing all 5 stages takes about 4 hours. 4 hours versus 40 minutes. Let that sink in, because on the busiest waterway in the entire country, that gap isn't an inconvenience. It is an economic weapon. In 2022, cargo turnover through that lock system hit 159.5 million tons. Now imagine shrinking a 4-hour bottleneck down to 40 minutes on that kind of traffic. That single difference can move the economics of individual shipping companies and of the whole country. That is the real reason a gigantic lift appeared on the side of the world's largest dam. So now I want to be straight with you, because this is the part the loud channels always skip, and it's the part that makes everything else believable. China is not the only country that can do this, and these systems have real, hard limits. The throughput of a ship lift genuinely cannot match an open river. It's one chamber, one vessel at a time, full stop. These projects cost staggering, eye-watering amounts of money. $777 million for the Gupatan lifts alone. Whether the return justifies that spend is a real debate, not a settled fact. Gupatan's dam, as I told you, is modest next to China's biggest. And, this matters, China did not invent the magic of floating boats over obstacles. The cleverest version of the Three Gorges lift was designed by Germans. The principle behind it is ancient Greek. China's achievement is scale and execution, not the original spark. And for the clearest proof that the West can build wonders too, go to Scotland. In 2002, the Scots built something called the Falkirk Wheel, and it is genuinely one of the most beautiful machines on Earth. For nearly 70 years, 2 of Scotland's great canals, the Forth and Clyde and the Union, had been completely cut off from each other. The old link was a punishing flight of 11 locks that took most of a day to climb, and it was dismantled back in the 1930s. So instead of rebuilding that grind, the Scots built a giant rotating boat lift. The final design was inspired by a Celtic double-headed axe, the propeller of a ship, and the ribcage of a whale. And it looks like all 3 at once, a sweeping steel sculpture. It stands 35 meters tall, about 115 feet, as tall as 8 double-decker buses stacked up. It has 2 opposing arms, each cradling a water-filled gondola, and as the wheel turns a slow half-circle, one gondola rises while the other sinks. It lifts boats 24 meters in a single graceful rotation that takes about 5 minutes. 5 minutes against most of a day for the old locks. But here is the genius of it, the part that makes engineers grin. Because of Archimedes' principle, a floating boat displaces exactly its own weight in water. The 2 gondolas always weigh precisely the same, no matter how many boats are in them. The whole thing stays in perfect balance, so it barely needs any power to turn at all. To physically lift 500 tons of water 24 meters into the air the brute force way, you'd need at least 32 kilowatt hours of energy. The Falkirk wheel does it on just 1.5 kilowatt hours per half turn, about the same energy it takes to boil 8 kettles of water. 8 kettles to swing over 1,000 tons of boat and water and steel into the sky. And to this day, it is the only rotating boat lift of its kind anywhere in the world. So, no. China does not have a monopoly on wonder. Nobody does. But here is the thing that stays with me. Stand at the bottom of Gupitan and watch a loaded ship rise 653 feet into the mountain air, then slip quietly into a tunnel bored straight through solid rock on its way to join a river that carries a fifth of a nation's economy. There is a person on that deck, probably leaning on the rail, watching the valley fall away beneath the hull, feeling something almost none of us will ever feel. The strange, impossible calm of sailing over a mountain. They are not thinking about gigawatts. They are not thinking about GDP. They are just up there, in the quiet, where boats are not supposed to go. The future people used to promise us, the one that always sounded like science fiction, is already here. It is pouring concrete in a province most of the world cannot find on a map, and it is not waiting for anyone to catch up. So let me leave you with this. If one country can lift an 1,800-ton ship over a mountain like it's loading a truck, what do you think they are building right now that we haven't even heard about yet? Drop your answer in the comments, and if you want to see it before the rest of the world does, subscribe, because you are going to want to be here when it drops.